morning, rise and shine. On the real, good morning, and welcome to the first ever Miss Stewart YouTube video. I'm gonna be famous, and I'm gonna rack up those stacks, if you know what I'm saying. But yeah, this is the first video, and for this one, I'm going to do both math and science in the same video. We're going to keep it pretty easy, pretty relaxed, pretty chill. This first week, I just want to make sure that you guys know what you're doing when it comes to logging into Zoom and the phone conferences and all that. So relax, calm down. It's going to be okay. So we're going to make this as cringy as possible because it needs to be, because that's entertaining. And we've all been bored out of our minds, stuck in our house for over 2 weeks.
Okay, I'm bored in the house and I'm in the house bored. Bored in the house and I'm in the house bored.
Am I right? All right. So sit back, relax, and get prepared to learn. All right, problem number 1 says, Tony creates a model of a building he wants to design using cubes. Examine the picture of his model. How might he use counting strategies to determine the volume? Pause the video, think about it, and I'll be right back.
10 seconds later.
All right, so that was not a trick question. It's as easy as it sounds. How can he find the volume? By counting. You count the cubes. If we take it way back to when we were in school before spring break and the coronation, we talked about how volume is the amount of space something takes up. We also talked about that in science. But yeah, so in math, when we're talking about volume, in 5th grade, we're referring to a rectangular prism. And we find that volume by either counting the cubes or, let's remember, multiplying length times width times height. But we'll get to that another day. Today, all we're focused on is counting cubes. That's it. All right, so let's take a look at this bad boy. I can see the cubes, but there's a little problem here. That's not a rectangle. It's like 2 and 1. So how the heck am I going to count these cubes? Well, if I look closely at this shape, I can see that there's a bottom layer, that base, and then on top of that base, there's this taller rectangular prism. So I'm going to first just pay attention to the base. Now, I remember that base is that bottom layer, and I can find the base by multiplying length times width. It's the same as area because it's only one layer. So I'm going to find the length, and then I'm going to find the width of that bottom layer and multiply them. So I can see that the length is 1, 2, 3, 4, 5 cubes, and the width is 3. 5 times 3 is 15. So my base has a volume of 15 cubic units. Now I'm going to take a look at that tall rectangular prism. Okay, so to find the volume of this, I'm going to find the length, the width, and the height. Or I can just count the cubes. Let's just go ahead and count the cubes of that rectangular prism. I can see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 cubes that make up that rectangular prism on top of the base. So 12 plus the 15 from the base, that's 27 cubic units. So this shape, that model of the building that Tony wants to create, it has a volume of 27 cubic units. Next problem. Part A. Tony uses two colors to prove that his model has two non-overlapping rectangular prisms. Expand on his thinking. Part B. Use your Unifix cubes to create a different model with the same volume as Tony's model. Now I know you don't have Unifix cubes right in front of you, but think about how you could create a model that has the same volume as Tony's. Stop the video and think about it for yourself.
I said stop. I said stop.
1 minute, 37 seconds later.
All right, so for part A, they're basically reiterating what we just went over in the last problem. They want to make sure that you understand that you can find the volume of the shape by splitting it into two separate shapes, like we did in the last part. So he made the base, that bottom layer, red, all right? And then he found the area of that layer. He saw that it was 5 by 3 by 1, 5 times 3 times 1, 15. And then he made the other part, that tall rectangle, he made that yellow. And then he found the area of that part that had a length of 2, a width of 2, and a height of 3. 2 times 2 times 3, 12. 15 plus 12, 27 cubic units. But we already knew that, right? All right, so moving on to part B. Part B is saying to use your Unifix cubes to create a different model that has the same volume. Well, we don't have Unifix cubes, so I'm gonna get up and we're gonna figure this out together. All right, so we know that Tony's model has a volume of 27 cubic units. And we want to think of another way to create a model with the same exact volume. We're going to use our multiplication facts to figure that out. So we know that volume is, say it with me, I can't hear you, length times width times height. So basically, I need to find 3 numbers that when I multiply them together, I get 27. So let's think. What are 2 numbers that I can multiply by and get 27? Cricket, cricket. Yes, you're right. 9 and 3. 9 times 3 is 27. 9 times 3 is 27. Now, let's think. Can I break one of these numbers up into 2 more numbers so that altogether I have 3 numbers that I'm multiplying? Yeah, any one of them. I'm going to do 9. So I'm going to break 9 up into 3 times 3. And then I'm just going to bring down the other times 3. So let's see if it works. 3 times 3 is 9. 9 times 3, 27. So if I create a shape, a rectangular prism, I'm trying my best to draw this 3D. You know, I kind of suck at drawing. All right, so if I draw this shape and I give it a length of 3, a width of 3, 3, altogether, it'll have a volume of 27 cubic units. Now that's it. All right, now, guess what? So exciting. You get to do the next 2 problems on your own. Or if you have a friend that you want to call up, FaceTime, that's in 5th grade at level, do it with them. Work together. I don't care, but stay 6 feet apart because that corona is something serious. Have fun. Before I go, I'm going to help you out with that next problem. The one that says explore some more. It says, Miguel builds 2 different solid figures with a volume of 18 cubic units. Each solid figure has a base of 12 cubic units. Use your Unifix cubes to help describe how the models might look different. All right, we get it. We don't have Unifix cubes, but you can still work out this problem. It says that Miguel has 2 solid figures and they both have a base of 12 cubic units. So, start off with 2 shapes, and each having the first layer made out of 12 cubic units. And then build off of that. You need to put 6 more cubes on each of those first layers. But they have to look a little different, right? Different shape, same volume. Like a liquid in science. Go for it.
Oh, say less.
Welcome back to my channel. It's time for science. So today in science, we're just gonna go back to where we were before spring break when we were talking about plant and animal adaptations. Yes, we're still talking about animals.
Look at all those chickens.
Back before break, we talked about how plants and animals have certain things about them, structural adaptations that help them to survive. For example, a tree frog has that green color that helps them blend in with the leaves, and it also has those sticky web feet that help them stick to the trees. And then you have stuff like mangroves that grow in the Everglades in that salty, marshy water. Well, if they were to soak up that salt water, that would harm them. So their roots are able to filter out that salt, kind of like our kidneys do in our body. Well, today we're going to talk about how animals have certain behaviors that help them to survive. And those behaviors can either be learned or they can be instincts. If it's an instinct, that means they're born with it. They come out knowing how to do that certain thing. If it's learned, then they have to learn it, most likely from their mother. You and I both have learned behaviors and we have instincts. While this video is playing, think about certain things that you and I do that we were born knowing how to do. Nobody had to teach us it.
Animal behaviors can be inherited, learned, or a combination of both. Let's look at some animal behaviors and find out where they came from. Spiders produce spider silk and use it to spin sticky webs. When insects get stuck to the silk, they become spider food. Is spinning webs to catch food an inherited behavior or a learned behavior? Nobody teaches spiders to spin webs. It's an inherited behavior. Let's try another one. Is this example an inherited or learned behavior? Prairie dogs use special, high-pitched barks to warn others of danger. A prairie dog will use this bark if an eagle is approaching, for example. Then all the prairie dogs in the colony run into their burrows. Are these special barks inherited or learned? They're part of a language that young prairie dogs learn. Ready for another? Is this next example an inherited or learned behavior? Sea turtles lay eggs in sand and then return to the water. When the babies hatch, they dig their way out. They immediately run toward the water. And if they're lucky, they reach it before a predator can reach them. There are no adult turtles to teach the babies to do this. It's an inherited behavior. Sometimes a behavior is both inherited and affected by the environment. A baby duck recognizes the first moving thing it sees as its mother. This is called imprinting. It follows its mother and imitates the mother's behavior. This helps the baby stay safe and learn how to be a duck. But what if a duck sees something else, like a human or a dog, before its mother? The duck will imprint on whatever it sees first. Can you think of other examples of inherited or learned behaviors?
All right, so inherited versus learned. Example number 1. Did you have to learn how to laugh? No, that is inherited. Now, what about math? Did you have to learn how to do math?
What's 9 plus 10?
21.
Yeah, and some of you are still struggling. So every day we have behaviors that we were born knowing how to do, that's inherited, and then we have those that we had to learn or have to learn as we grow older. Some more examples to think about. Hiccuping, breathing, writing your name, running, falling asleep, reading. Were each of those learned or inherited? Think about it. I'm going to ask you.